Well, hello everyone, Maple Structure here, and in today's video I'd like to show you how to analyze simply supported beam with uniformly distributed load. So enough talking, let's get started. Well, first things first, and let's take a look at the structural model. Well, it's just a beam, no matter what the cross-section is, and it's supported by a roller and a pine supper and loaded with uniformly distributed load, so it's easy. The system is in equilibrium, and that simply means we can use the rules of statics to find the reactions at supports A and B. So let's assume the vertical reactions are directed upwards. If it's wrong, the equations will show it to us later, so don't worry about it, it's just an assumption. Well, next, to make the next analysis a bit simpler, let's replace the distributed load with its equivalent concentrated load. And we find this resultant force by multiplying the load intensity by the total length of the beam. To write the statics equations of equilibrium, we need to introduce the x and y coordinate axes. So now let's sum the all vertical forces along the y-axis, taking their signs into account. So as you can see, we cannot find anything from this equation, so we have to write another one. And now let's take the sum of moments about point A, assuming counterclockwise moments are positive. And now we can easily find support reaction at B support, and then put it in the first equation we wrote and find reaction at A support. So now that we have determined the unknown support reactions and their directions, we can proceed directly to finding the shear forces and bending moments. We will be using the method of sections, so we have to make a cross-section of our beam here or anywhere you want, and take a look at the left part of the beam. So let's assume the right end of our beam is point C. Since we are dividing our beam into two parts, we must replace the right section with internal forces, specifically a shear force and the bending moment, just to ensure the remaining system stays in equilibrium. So now we have to repeat our previous steps and write statics equations again. Now we want to determine shear force at first, as you can see on the screen. As you can see, we have obtained a first degree equation with variable x, and to plot the final shear force diagram, I suggest evaluating with the two extreme values of x, where x equals 0 and where x equals the full length of our beam. Then we can simply connect these 2 points with a straight line. So now let's move to the bending moments, and here's the same actions. We have to write a sum of moments about point C and determine the extreme values. So as you can see, we've got a quadratic equation with respect to x. And this tells us that the bending moment diagram will have a parabolic shape. So based on this, we need to pick at least 3 points so we can connect them with a smooth curve. I suggest evaluating the 2 endpoints and one right in the center to determine the maximum value. And now we have all the values we need to finally plot the internal force diagrams. So no extra words, you can see those diagrams on the screen with all values of shear forces and bending moments we've determined before. And with that, the analysis of our beam is complete. But before we end, I'd like to show you how to make these analyses way faster just by using 2 formulas, so next time you don't need to make all the previous steps. Through some simple manipulations of our previous equations, we can derive these 2 formulas for the maximum internal forces. And knowing them allows you to jump straight into plotting the diagrams without any calculations we did before. And on that positive note, I'll wrap things up. If you have any questions left, I'll be happy to answer them in the comments below. That was Maple Structure. Peace.